interference on the line.
Truth and lines of the energy transition. This is Cleveland Jones, Professor Cleveland Jones. This is Paul Taylor, consultant. And this is Armando Cavani. It's me. Professor Cleveland. The idea is to each one presents a slide, one slide, and the others comment after that. So can you start with your first slide?
Yes, sure, Cavania. It's nice to talk about a topic that probably will have a lot of pros and cons being commented. But the first one that I chose is green hydrogen because it's touted as the fuel of the future. You know, you generate electricity, such as shown in the picture, either wind or solar, green energy, and you send it to an electrolyzer. You send it to a substation. You send it to an electrolyzer. You produce hydrogen. Then you ship the hydrogen to where it might be used. Theoretically, it looks pretty straightforward, a couple of steps, but it really is quite unwieldy. So I would say this is a lie. Green hydrogen cannot really be the fuel of the future. And I say this because I really believe that there are many high inefficiencies built into this chain of events, the sequential energy conversions, and because of entropy limitations. And, entropy limits the efficiency of an energy conversion process, whatever it is, from solar to electricity, from wind to electricity, by limiting the amount of useful work that can be obtained from the input energy. And as the entropy of the system increases, it's even more difficult for the process to occur. So the efficiency is even lower. And the more steps you built in, the more difficulty you get in terms of decreasing efficiency. So, one of the realities is the wind conversion from wind to electricity isn't that high. Sure, there's a lot of wind going up, but the intrinsic efficiency of the conversion is only 20%. The electrolyzer, forget the electricity from the wind turbine to the electrolyzer where there's losses, but the electrolyzer itself, even though we've made great technological progress, the efficiency there is also not very, very high. It's 75% at most. But there are also high electrolyzer problems, such as degradation of the electrolyzer functioning with time, the more it works. And currently, the best degradation, the minimum degradation they've achieved is something like 10% per year. So you're talking 10 years, the working of an electrolyzer will be seriously compromised, requiring maybe changing equipment and so on. This greatly reduces the attractivity of the method. Then, of course, there's transmission efficiencies, distribution inefficiencies. The transmission is somewhere like 85% efficient. It's pretty good. Distribution is maybe 90. It can be a lot worse in many places, including in Brazil. And then the hydrogen fuel, after it's produced in the electrolyzer, the round trip storage efficiency of hydrogen, because you produce hydrogen and you got to rush it off to a consumer. But you might store it for periods of high consumption. You might transport it in whatever means there are. And that is still very difficult. Hydrogen is a problematic molecule. There, the efficiency goes down to something like 40%, in some cases less. And the hydrogen compression, liquefaction, that efficiency is horrible. If you really have to ship it far away, it's horrible. That's why many people are considering, other alternatives, ammonia, methanol, and so on. So the overall efficiency of green hydrogen is extremely low. I mean, if you multiply all this out, it's 2%. Say that it's 10% or 4% or 5%, whatever. It's still very low. And this argues very strongly against it. So this, I think, even going forward, if we make some technological advances in reducing inefficiencies here and there, it's going to be very difficult in 10, 15, 20 years to reduce that inefficiency a lot. I think that's the main problem. So for me, this is a lot.
Yeah, Cleveland. People say that we spend more energy to make green energy than the
Oh,
energy delivered.
for sure, for sure. In fact, I don't think that in itself is a great problem, such as, for example, the wind conversion efficiency. As long as you have plenty of wind, so what if it's inefficient? You convert some of it. If it's still economically viable to do so, that's fine. The only problem is that when you compound such inefficiencies, and many of them in technologically impossible ways to fix, such as energy conversion inefficiencies, it becomes difficult to have an overall process where you get hydrogen or electricity or whatever to where you need it in efficient ways.
Paul, your comments about this slide?
Well, I hear a lot of people saying that hydrogen should be the way forward for the future, but I don't think people have considered one, the safety, the security, nor the cost of generating and transmitting and storing hydrogen.
Yes.
Yeah, yeah, good point.
Yeah, there are a lot of people there that are just dead set going against the nature of hydrogen, which is very complex, very difficult to handle.
Yeah.
Now, I don't think that is an impossibility to overcome, as maybe we'll touch on later, but it certainly makes it very difficult. And in the time frame of an energy conversion, of a transition that must occur, and as the stated goals are by 2050, that's 30 years or whatever way, but still, that is very difficult to achieve in that period.
So,
Perfect. Let's go to the second slide.
Yes, fine. Yeah, I also wanted to touch on wind energy because that, of course, is one of the success stories in energy transition, and certainly in many countries. Brazil is one of them. Wind energy has grown tremendously, onshore in particular. Now it's even growing offshore. In the North Sea, of course, it's a reality offshore, and in China and many other places is growing tremendously. So people are naturally suggesting that wind energy will be a major part of the energy mix in the energy transition because it's clean energy. But I, again, come up with a conclusion that I suggest is a lie, at least in the medium and long term, because wind energy indeed has been growing and is growing tremendously, but in the time frames that we are considering, by 2030, 2040, 2050, it will grow, but it cannot become as large as many analysts expect it to in order to provide a major part of the support for the energy transition. And this means that it has to be quick. If we look at long-term of the energy story, just as we've had fossil fuels are a blip in history, if you look at centuries, I think that wind energy, even after 2050, might actually be a blip. It will exist and it will be a part of the energy transition. I argue that it won't be a major part of the energy transition.
Paul has a question for you as well.
no, sorry, that was the last slide, Armando.
Oh, okay.
Yeah, well, the same thing applies. Efficiencies.
Before Paul, before you go in your comments, Cleveland, the intermittence of wind energy covered by natural gas is something that is a concern.
Well, this is again an area where we didn't touch on a lot of lies and a lot of truths. And indeed, intermittency, I think, is overblown as a problem. Intermittency is just a reality of some energies, and you overcome that with storage. Well, of course, storage may be very expensive, it might be not viable for certain cases, but intermittency by itself is not an insurmountable problem. And in fact, wind energy has both that problem and also some cases where intermittency is almost not a problem. Here in Brazil, in the Northeast, it's one of the regions in the world with the lowest intermittency for wind energy in the world. So we have almost steady generation. Not steady,
Wow.
of course,
Wow.
but it is a very important differential. That's why some of the wind energy rates are among the lowest, because you don't have so much intermittency. But yes, you will still need storage, and its low efficiency and the
Sure,
costs
sure.
are
Batteries and
already
so on.
about as low as they get.
Paul, you are participating too. So
Yeah.
please
Well,
go ahead. Your comments.
my comments about wind is surrounded by, I think you've touched on the materials, but it's the transportation of those materials to the wind farms. We've seen these pictures of these gigantic wind blades being transported, and
Yeah,
that's quite a big issue. But what if one of them, there was one local to where I live, caught fire? The repair or replacement of that wind turbine is going to be difficult as well as very expensive.
Paul,
Yeah.
you are talking about logistics to move these plates. Is this the point?
Partly, yes, but then it's the logistics surrounding the repair of these units when they break down, or if, as I said, one of them caught fire. But even the logistics of moving the energy from the wind turbine into the
That's right.
grid.
Yeah.
Good point.
But you see, again, I continue to hold that this is a lie, that wind energy will have a very tough time being a very significant portion of the energy mix in the energy transition. But I beg to differ. I think the logistics problems are indeed challenges. But you see, wind energy is being currently developed in large scale, mostly by the oil companies. And they are the ones who excel at handling logistics problems. I mean, FPSOs, rigs, drilling rigs of all types, ships, that's their business. They can handle big projects, big challenges like that. And I think this is one of the few energies that they may be very good at in developing. It's still not going to make a major difference in 30 years, but I think that that's surmountable because, indeed, logistics is an engineering problem, and we've been very good at solving those. But I agree that, we've got technical limitations which may be very difficult for technology to solve. Maximum size of individual turbines, there is actually a technical theoretical limit. We're close to it. Maybe they're up to 20 megawatt. We're close to that now, so you can't expect efficiencies or scale benefits to benefit much from growing in size. And indeed, the materials present another problem, not so much just logistics, but maybe geopolitical. The sourcing is all China. Even the actual supply of some materials may not be available, no matter what the cost. For example, some critical materials may not be there. And that's a very important part. In fact, wind energy has come down in price a lot, but the latest trend has actually been increasing in price a little bit from the very low levels.
Paul, did Cleveland explain well these points?
No, very well. And in fact, he's touched on some of the points I'll bring up in my presentation.
Okay.
It's good.
Yeah, the last thing I wanted.
Let's go.
No, I just wanted to mention one more thing. A lot of times we talk about, new energies that will come into the energy transition. But if you have to bring in a new energy that you have to replace every 20, 30 years, such as wind energy, the turbines, the blades, like Paul said, these are not everlasting pieces of equipment. That means that in 15, 20, 25 years, we'll be running on a treadmill just to replace what we've got before we put in new stuff. It's going to be very, very difficult. And I don't see that changing in a material way. Yeah.
It's a challenge, for sure. Cleveland, your third slide, please.
Yeah. And again, this is a very important concept because electrification is underpinning a lot of the energy transition concepts that we hold very dear. Basically, electrification will have to occur and increase tremendously. And in fact, some people are talking about full electrification as if that were possible. And again, I say that that's a lie because electrification, especially full electrification of the economy, is basically impossible, certainly impossible in 20, 30 years, which is when we want the energy transition to be in place. Electrification presupposes very much new equipment, a lot of new equipment, a lot of new transmission equipment, and there's already a lot of accumulated demand from maintenance that hasn't been performed over the last 10 or 20 years. So there's a pent up demand for transmission and so many other pieces of the electrification system, all with very high capital expense elements. So maybe the cost is not, the operating cost is not so high, but all of these entail very high capex, from building new transmission lines, distribution lines, all of the electrification equipment that goes in, very, very expensive, and all with significant environmental impacts, direct and indirect, even from the materials they use. You know, that's a very important element of it.
I have a comment, Paul, before you enter your. Let me make my comment like this one.
For plastics, molecules for fertilizers, ammonia for fertilizers. The world needs both. We're not going to electrify everything.
Yes. Yeah. That, you know, he's always right, or at least in this case. Some say, but it is impossible to electrify everything. Maybe in 100 years we might get to that point when fusion is there and everything is smooth. You know, we have to be realistic. We're talking about 20, 30 years to make a transition that is extremely impactful. And like I said, with a lot of environmental impacts that people are not ready to accept.
And in 100 years, Paul will be 150 years, so it's not too much. Paul, your comments on electrify everything?
Yeah. Electrification is obviously a bit of a holy grail. Excuse me. But the wealth distribution is not equal across the world. Many countries simply cannot afford the capex nor the opex. But then when you compound that with security issues, stealing of the electricity, as you see in many, many countries, vandalism, decay and deterioration because of the climate, it's going to be very, very expensive to employ people to monitor and safeguard the grid and the network.
Yes, you see, in Brazil, for example, I'm in Brazil, even the existing electrification system, which is transmission lines, not so much, but distribution lines, they are nothing more than a source of income for a lot of people who basically steal the cables and the wires and even equipment. And the challenges in dealing with this kind of vandalism and losses is tremendous. And it's a cultural thing. You don't change people's culture in a short term.
Right.
You know, it takes a long time.
Cleveland and Paul, and the dependence on only one manner to have energy is something that's dangerous. So you do not have contingencies and alternatives with other sources.
I admit that you could have alternative sources for the electric energy, but to have all your eggs in an electrified economy is currently not only a challenge, but an impossibility. And in fact, you know, there are some sectors which are currently, I won't say impossible, but in the long run, but they're currently impossible to electrify in the timeframes we're talking about. And we had a program a while back about energy poverty. This is a dream. in a lot of places in Asia, Africa, Southeast Asia, even Latin America. We're not close to electrifying the economy because we have to
Yeah,
focus on cheap fuels all the way from coal to oil and even gas, and it's not going to happen right away. It's a
Perfect.
first world type of problem.
Yeah.
Perfect.
Yeah.
Okay, going to your last slide. You have any,
Okay,
Jones?
now hydrogen is the fuel of the future. Remember, I first said green
It's the same
hydrogen.
question of the first slide.
No, this is different. I said green hydrogen is the
Oh,
fuel of the future. No, that's not true. I said now I say I say hydrogen is the fuel of the future, and I believe that is true. I don't know exactly that it will be true by 2050, but it will be very close. And the reason is that I think hydrogen, as opposed to green hydrogen as an energy carrier to supply the energy demands from generation to applications to industrial uses, may indeed come very close to being the fuel of the future.
but with no
Obviously,
safety issues. No safety issues.
there are safety issues. That's why I'm saying is the fuel of the future, not the fuel of the present, not the
Depends
fuel
on
of the next
technology
20 years.
disruption. So that.
Exactly. I think it will take indeed some 20 years to make hydrogen viable as an energy carrier for the economy, to make it possible to become predominant throughout the energy chain. And this is a major step change. And I think that the engineering problems of dealing with hydrogen will come about in 20 years or so, or certainly in 30 by 2050 when we're talking about the energy transition.
Yeah.
The key that people have argued about is the source of hydrogen. And this is where I think we're different.
I understand you. Paul, I do not agree with him, but maybe you can agree.
I don't know. I simply don't have a comment on this one.
I know this is far-fetched.
Yeah, I have to sit back and think about this one before I can comment.
Well, this is the problem when you take someone with a geology type background and with a new technologies type focus, and you mix them, you might get something that's not realistic, such as some people might
more
think
a dream.
this is. Yeah. So I agree. There could be a lot of disagreement here, but I hold to this because, like we said, call me in 2050 and tell me I'm wrong, but there's a good reason why I believe this is true, and that is white hydrogen, which is very prevalent in nature.
Yeah,
exactly.
Cleveland.
Yeah.
We have a person, Carvalho, saying that does not agree with you here.
Okay. Oh, Luis, yeah. Well, the problem with arguing against hydrogen is that for those who believe in decarbonizing our energy mix and economy, this is perfect. So, it would seem to be true. To those who think that, well, drilling and so on or mining things is very has a big environmental foothold in the economy, you have to realize that some of the solutions that we're looking ahead to are employing existing technology, not relying on too much major changes. In fact, light and gold hydrogen rely on existing technology.
You are predicting because you expect that we have a technology disruption soon, and we can move
but
this
only
situation.
The technology disruption that I foresee is really in handling hydrogen, because hydrogen theoretically is extremely attractive, and everybody understands the theoretical side. They just disagree because in practicality, difficult to store, to transport, inefficient, and so on. But I'm saying we're on the track. We even have solid storage, all kinds of things.
Yeah. Because
Paul, help me.
Well, you used the word difficult, Cleveland. You didn't use the word impossible.
Right.
And that I agree with. It is going to be difficult, but we have the technology. It's mostly related to cost.
Yeah. This
And
is
safety.
where,
And
this is where engineering comes up with the solutions. I mean,
Yeah, that's right.
we've had the same kind of disruption that we saw in the shale gas and shale oil boom. That took 10 years. You know, that's not a long time. Even if we start this revolution in 2025 or 2030, it can be ready, or in 2035, it can be ready by the energy transition deadline. So it's viable in theory, and of course the solutions are almost there. Certainly when you talk biological solutions for production, we're very close. I mean, we're in an age where we recognize that biology holds the answer to many of the engineering problems that humanity faces.
that's interesting.
Okay. Yeah. May I start with my
Yes.
two? Hydroelectric power. So people saying that solar technology produce at least amount of pollution when comparing with fossil fuels. And the point is, looking to the CO2 and methane, this is true. The pollution, they say, of fossil fuels. However, mining of lithium and other minerals are extremely impacted in terms of environmental position. And the disposal, as you said before, Cleveland Jones, and deposit of materials, so for not more useful equipment, something complex and dangerous. So it's true, but looking only to CO2 and methane issues, not to the total process, the end-to-end process is my thesis.
See what Paul thinks.
Well, I was going to bring up a very similar point in my presentation. How many lithium mines are there in the world? And then it's all about scale, because those lithium mines, there's less than a dozen. How many tens of thousands of oil installations do we have offshore? All those nodding donkeys sitting onshore, surface treatment plants, pipelines, all potentially polluting. So I think on a scale, I think the mining argument is not a good one.
Yeah, let me throw something here. I agree that there is an environmental footprint to all of these things, and we can balance some of them. But you have to realize, as to the oil and gas industry, a lot of that footprint has already been stepped on in the world. You know, the oil wells were built and drilled, and the fluids were taken out, and so on in many cases. So if we can envision a way of utilizing those facilities for new energy without significant new impacts, I think this would be maybe a way of diluting some of that environmental footprint and, in fact, getting something out for no additional environmental footprint.
Yeah. So, Paul, you do not agree that mining is something, let's say, stronger enough to beat this CO2 and methane pollution? Is that the point?
No, I think it's just a matter of scale. As Cleveland said, everything has a footprint. We have an impact on the environment, not what we do. Taking lithium as a specific example, most of the lithium mining mines are in very remote locations in the world. They're a small, very small dot on the landscape globally. Where, and to repeat what I said, we've got tens of thousands of oil installations which could be leaking into the ground or flaring into the atmosphere. Refineries, everything, surface treatment plants, pipelines that are leaking or have been vandalized because people are trying to steal the hydrocarbons. So it's just a matter of scale. Everything that we do has an impact.
Yeah, Paul, the scale is the key as well as the time frame.
Yeah.
But look at this. You've just said that there's tens of thousands, maybe a lot more in terms of onshore wells and so on, hundreds of thousands. If they can become part of the solution to the lithium problem, and I think they can, they will be. I'm convinced that lithium production will come from onshore oil fields in mostly in the U.S. to begin with.
Yeah.
And the scale can be increased tremendously. And I think when we make forecasts, if we're just going to extrapolate, there's no science in it. Why invite Paul or me or Kamanya to talk about it? If you're just going to extrapolate what was in the past, you ask a sixth grader to do it. I think what we are here to do is to envision a different possibility. The fact that lithium will not be limited by the existing mines, but rather will have a very bright future from alternative sources. But that's for lithium only. I'm not saying, cobalt, nickel, copper, and so on. That may be a different story.
Yeah. Let me show a question from Carvalho. It's very important to emphasize here that today's 100 million tons of H2 black consumption today needs to be fossilized. Yep.
Impossible to do in the short term. I agree.
Yeah, perfect.
So scale and time are the key here. If you need to do it,
that's right.
Big, fast, impossible.
Yeah, but you've also, as you've already touched upon, Cleveland, you're trying to change a society's way of thinking. They get up, they put petrol or diesel into their vehicles and drive to work.
Yeah.
And they are very happy doing that. The anti-EV or electric vehicle grouping, here, especially here where I live in the UK, is huge. Yeah. You start talking about, I'm going to buy an EV, or you better duck.
Okay, let's go to the next one. Is Mr. President, we will need oil for much longer than 10 more years, much more. 30, 50 years, I don't know, because logistics based on liquid fuels is something very dependent for ships, trains, heavy vehicles. And of course, for petrochemical products, 6,000 petrochemical products that oil, 30% of oil demand in the world are provided nowadays.
It's impossible to do this.
It's not 10, but maybe 50 years from now, oil will be very important.
I think oil has got a future for at least 70 years. But what you need to be careful of is who do they mean by we? Because there are countries in the world who have a lot of oil, but they don't have the infrastructure for hydrogen generation, wind or solar, and they're sitting on a wealth of fuel. Now, that wealth of fuel may not be cash wealth in the future, but they will have cheap fuel to run their vehicles, their power generation, everything. They're not going to be in a race to convert.
But you see, even ADNOC and certainly Saudi Arabia and so on have said that they plan to use their hydrocarbon wealth, which is energy, conventional fossil fuel energy, to produce green energy. And, even if the conversion is not very efficient, they have more oil than will likely be produced in 100 years. So it's no loss to them. And they will be able to export ammonia or hydrogen or whatever you want in alternative energy.
Forget hydrogen, Cleveland. Yeah. Forget hydrogen. you love this solution. I hate this.
No, I agree. But they will, even electricity, they can provide electricity for export. And this is more and more going to become possible in South Korea. We have relatively high temperature superconducting transmission lines. This opens a whole new opportunity for long-term long distance energy transmission in the form of electricity. We're beginning to scratch the surface of major disruptions. We just don't see them because we're all focused on filling our gas tanks. We have to open up our eyes and see what's there. It's not going to come immediately, and it's not going to come very big way, but the changes are there.
And I've got one point there, Armando, is that recently there was a ship set sail that had sails as well as diesel engines. And I also heard about the first full electrical plane flying.
Yeah.
So it's
all new ideas look foolish when they're still only an idea,
Yeah, but they're a bit more than an idea now.
Yeah.
But the cost is going to be against them, but the technology is evolving, and we'll eventually we'll be getting on a Boeing electric plane rather than jet fuel.
But you see, it's difficult for us in the energy scenario to understand some of the changes that are happening. For example, with internet and the computational advances. Artificial intelligence is already in the oil and gas industry. Sure, they're using it for exploration and optimization of facilities, but artificial intelligence is what will speed up some of these innovations to the point where they will become real.
But artificial intelligence does not create energy.
No, it makes it possible for the processes
optimize processes, but do not move the 100 million barrels a day that we need in the world nowadays.
No, but it can be used to generate innovation.
Artificial intelligence is what's going to move innovation in all ways. If you can find out the materials that make something, 10% as expensive or twice as efficient, that can speed up the whole cycle of implementation of a new technology. Instead of taking 15, 20 years, we compress that.
We optimize systems, but do not move systems in a hard direction.
If the shale revolution was beginning today, it would not take 10 years. It would take 5 or less to become a reality. Because of artificial intelligence, we just don't grasp how much this is advancing all fields, including very traditional, heavy industry engineering.
But with some limitations.
Yes, some.
Let's. This is for Cleveland Jones. Oil reserves will not run out in 10 years or 20 years. Will remain for a long time. Cleveland Jones.
Yes, I've said that, people are worried about, exploration shortfall in investments. Yeah, I believe that converting some known resources into producing resources, that is not really frontier exploration. So you need money for that. But the known oil in the world, we know that it's there, is more than enough to carry us beyond this century. Even if we remain,
we have reserves enough to make the energy transition.
Of course, even to the end of the century at 100 plus million barrels a day. This is a reality that people don't want to believe because they think, we have to change. But oil is there and it's available and it won't be very expensive.
Well, we always forget with our existing fields that we're leaving 60% of the hydrocarbons in the ground because of the recovery factors.
Yes.
And one day somebody, maybe using artificial intelligence, will come along and say, we can get another 20, 30% out of the ground from the same
huge volume.
field. So, because I worked on a project in Shell where we had 26% recovery factors, and our goal was to get that up to 35. That's a huge amount of oil in a 1 billion barrel field. So
this is happening all over.
Yeah, exactly. And oil companies they certainly were looking at improving recovery factors rather than exploration.
You see, even big companies Of course, in the North Sea, there are fields at getting close to 70% recovery factor.
Mm.
Here in Brazil, Petrobras was a major operator. They disinvested some assets, sold them. Some companies bought some of those onshore assets. In 2 years' time, the
But it's
recovery
not
factors.
reality. But it's not reality now. The 27% is a good number of recovery. So,
Yeah, but the new reality for the companies that took over those same assets is 35-40% recovery.
Yeah.
So it shows that it's
some
possible, and
types,
they're making
some types
money.
of reservoirs, yeah.
Yeah, they're making money off of it. And of course,
Sure.
in some fields, especially big ones, you can aim
Yeah.
for higher because they allow you to
Yeah.
make the investments
my-
with scale.
Okay, my point is that the reserves that we now just have
Yeah.
are enough to
Sure.
make the complete energy transition.
And they are the reserves are extractable. They're producible at very
Yeah.
low prices. This is a reality. People think, oh,
And
we need
artificial
200.
intelligence can help.
Yeah, and we don't need $200 oil.
Well, let's go to my last slide. We just talked about that, and Cleveland said that in north part of Brazil there is no intermittency. So I'm
Literally.
fine. I'm fine. Paul, please, your slides.
Okay. Well, I'm taking a slightly different approach to you and Cleveland, Armando. Basically, the key factors for the energy transition are geopolitics. We've got the war that, no, sorry, it's the special military operation. I must be politically against Ukraine. Has put a spotlight on Europe's dependence on fossil fuels, and of course, with the attack on the pipeline feeding all that gas to Germany, and yeah, so Europe realized that it needed to wean itself off the fossil fuels, but also with the goal of going to net zero. I think it's by 2015. Really does mean that we have to generate electricity from hydraulics, solar, wind, biomass, hydrogen, and nuclear energy sources. But the pathway to greener energy has some very hard truths that should be considered, and they should be considered more openly. So we have these energy policies, but we have to be skeptical of those because, as I've already said, global wealth distribution is very unequal. And so we can't have blanket policies coming out of organizations such as the European Union and the United Nations. And a lot of announcements that you do see or hear, they're not always based on science. So if we can go to the next slide, please.
Sure.
So way I'm approaching this is the pro-transition camp. They say things which are, I believe, are lies. For me, the greatest lie is that there's an endless mineral abundance. Did you know that the average North American citizen consumes 1.3 million kilograms of minerals, metals, and fuels in their lifetime? Now multiply that by the population of the US, and you've got a huge amount of mining to do. Now, nearly all consumers, they don't have any idea where those minerals come from, what the cost of extracting them are, what the impact they have on the environment. Do they really care? I don't think so. As long as they can buy it, they're happy. I could be wrong. I'm willing to discuss that. So urban consumers, they have very little knowledge of energy realities. Now, renewables, and Cleveland has already touched upon this, they do have a cost. and it's quite considerable. The cost of building the initial installations, whether it's solar or wind farms, yeah, they have a cost, and it's quite a huge upfront capex. And talking about solar, even the best countries in the world for solar, they only have 8 to 10 hours of operation time every day. So you have to be very careful about statements about renewables.
So are you saying that there are lies in this slide? So renewables are not expensive? I didn't.
No, renewables are expensive. I
Yeah,
believe.
these are untruths.
Okay, untruths. Okay. Oh, yeah. Sure.
But let me say something, Paul. When we spoke about lithium, I said, I was optimistic, and I think, well, lithium is not going to be a problem. But of course, the energy transition requires a lot more than just lithium. It requires aluminum, copper, cobalt, all these kinds of things. And some of them, the barriers to expansion of supplies are not even geological, even though some of them are. Copper, I think, is going to be very difficult to increase, silver, that kind of stuff. But, if you look at some of the mines in Africa that are producing minerals that are essential, and at the social costs of these, and you say, we can't afford to, morally, as a world, we can't afford to demand that those countries bear the social cost of producing minerals like that, then we're up against a real problem. And I think this is a real
You are saying that using these minerals are immoral.
In many cases, I think so, because we use them because we want them and we can pay for them. But if we look at the face of who's producing them, oftentimes kids and so on,
social
with
labor,
early mortality because of the conditions, is that what we can accept as part of the transition? I think obviously not.
Yeah, and one of the things we've got to remember with lithium specifically is that that's just a small piece in the whole machine, because lithium is used to create batteries, to store the electricity, generating the electricity, transmitting it to the consumers is a totally different thing.
Perfect.
Again, and you basically, to create a grid and storage for that generated electricity requires huge investment, and both governments and private sector need to put in that money. Not everybody's familiar with this. They're not familiar that there is a price to generating electricity. You're not just paying for it, there's a cost to generate it and get it to every building, every business on the planet.
Paul, maybe I can one day talk with Cavani about a whole other topic, which is energy storage, because you talked about batteries, and in fact, lithium for batteries is what everybody understands. But storage goes way beyond that. And at the scale of the energy transition for supplying the world's energy need, we obviously need something that's not batteries. That is not going to carry us. So storage is a whole new topic. But this brings up the fact that we have to discuss things that are just not popular. Rare earth minerals, elements that are going to be very difficult to produce at scale. Yes, we can increase scale tremendously, but the need is so much higher than that. The salars in the triangle in Bolivia, Argentina, and Chile, yes, that's very promising, but we need so much more, and it's difficult for people to grasp the scale.
You're right.
Exactly, that's my point. People, those who are against electric vehicles, they will put up those posters showing that you've got an electric car that's either being recharged by a van that's diesel powered and has a generator in the back.
Yeah, that's a good point.
There's no real science behind it. It's just emotion.
Politicians, yes, you're right. No science in this. Yeah.
No.
Let's go to the next one.
No, the last point is quite important, because quite often you hear that this target of 1.5 centigrade by 2050 can be
It's a
achieved.
lie.
It's definitely a lie. They talk about social change. Yes, there are costs. People have to pay to have heat pumps installed in their homes or in the factories and the offices. There are costs, but I found out that the current cumulative estimate is $1.5 trillion.
Yeah.
So that's averaging $5 trillion per annum to reach that target of 1.5 degrees, or keeping the temperature rise to 1.5 degrees C by 2050. Yes, it's achievable, but it takes a huge investment.
Well, at this point, I don't think it's achievable. Maybe 2 degrees we can try to hold under those terms. But when we first discussed trillions of dollars in investment required, I think we did this when we talked about energy transition a while back. I think people were taken aback, but we have to talk about trillions.
Yeah, but Cleveland, we need to make sure that these two degrees are related to human efforts.
Oh, no.
Or not.
It doesn't matter. This is the way we're going. So whether it is or it isn't, the energy transition is being propelled, regardless. Unfortunately, it's not so much based on that. Yeah,
that's right.
Okay, we can go to the next slide now, then, Mondo.
Sure.
Okay, these are the arguments I've seen given by the people who want to keep. They want to keep the same situation, the status quo. Yeah. Endless mineral abundance. Well, that's not true, is it? Because we all know that we have a finite amount of oil, we have a finite amount of gas, we have a finite amount of everything. It's not endless, and it's certainly not cheap to get out of the ground. The capital expenditures that the mining companies have to face are quite horrendous to dig those massive holes in the ground or to sink shafts. I used to be a mining engineer a very long time ago, and the sinking of shafts is the biggest cost of opening up a deep mine. Mining is expensive. We all know that. But is it really a greater environmental hazard than fossil fuels? I don't think so, because we covered that point a few minutes ago. We have seen these pictures of these large open cast mines, maybe hundreds of meters deep, and then there's an area in Brazil, which I used to really know the name of, but I don't anymore, showing all these poor guys working in mud. Yeah.
Okay.
But certainly in Europe, I can't comment about the US because I don't know, but in Europe, they tend to restore those mines to better than what was previous.
At great cost.
Yeah. So I don't believe that at all. Now, the other one is renewable technology cannot or will not replace fossil fuels. Yes, it can, but it's not going to be an easy task. And according to a Wall Street Journal essay, is when you factor in chemistry, physics, material science, carbon capture, software, and data analytics, the scope of these hurdles are enormous, but they're not overwhelming. Just like you, Cleveland, you said it's difficult. You didn't say it's impossible.
Yeah, that's it.
It's enormous.
Only a remark. We have almost a 1 hour conference, so
okay. So infrastructure, basically infrastructure, it does exist, but for things like green hydrogen, a lot of the questions are basically, can your turbines burn green hydrogen? How much hydrogen can they burn? But the answers are, yes, we can. How much hydrogen do you have? So you're putting the ball back in their court. Can you transport that hydrogen to where we need it? Are your consumers willing to pay that cost?
The infrastructure cost there is certainly an issue because you can always build infrastructure, but it's expensive. We're talking trillions, as we said, trillions of dollars per year.
And it's also a question of how fast can you build that infrastructure?
That's right.
And it requires minerals that may not be scaled up, as you say. Sometimes it's not a question of the price goes up and we can start mining other deposits. No, in copper, we do not, as a world, know of resources that can be exploited, even if the price is triple, because we do not know. Of course, we might in the future, but we don't know. So there are some physical limitations as well.
Okay, we can go to the next
Going to
one.
the last one. Yeah.
Yeah.
3 minutes. 3 minutes.
So here are some truths. The world currently depends on its fossil fuels for 84% of its energy needs. And I don't think anybody can argue with that, whether you're pro-transition or against transition.
Yeah.
That is a statement of fact. But what is the Holy Grail? It's going to be a difficult objective to achieve, but mostly from a technological and a cost-benefit standpoint. But it is achievable, and you just need to have the policies and the philosophies in place to be able to do it. See, I think we've all said that the technology is not an issue. Investment will be an issue. And it's going to take investments both from the private sector and government to help make this happen. But we have a window of opportunity. The upper limit, it can't be too rapid because society needs enough net energy to function without any disruption. But the lower limit, that's dictated by the minimum speed to meet the ambitious climate targets. And those two limits are fast approaching each other.
Yeah.
So the window of opportunity could disappear, and we have to be careful of that.
Yeah.
Thank you.
Very good.
Very good. We have several comments from Luis Sergio Carvalho. All of them are in LinkedIn.
Okay.
So you can go there and answer directly to him.
Maybe, Luis, we can talk a little later in LinkedIn about some of these thoughts.
Yeah, that's right. So what's the main truth and main lie?
You know, Cavagna, there's a guy, Rob West from Thunder Set. I think he's the smartest guy that I know. He writes a lot about energy transition opportunities for business. You know, he looks at opportunities for investment, companies involved in this, that, and the other. And I think if we take a viewpoint where we see practical challenges that we have to overcome to make things happen, then we find answers that are not so ready-made and being
Ready-made,
discussed
yeah.
all over.
Yeah, perfect. Paul, your conclusion.
The difficulty I had with this was it was easy enough to find academic corporate articles about pro-transition. The anti-transition,
Yeah.
I was even getting dead quotes from dead geologists. And I found it very difficult to believe what they were saying.
Maybe they'll quote us now. Of course, not a rigorous article, but opinions nevertheless.
I just hope they don't say, "Oh, those dead podcasters."
Thank you
Very
so
good.
much, Paul Taylor and Cleveland Jones. It was a pleasure.
A
Thank you.
pleasure.
Thank you so
for
much.
us too. Bye-bye.
Bye bye.
Thank you. Bye-bye.